Hello. So this video, I'm going to cover some problems on related rates from chapter 4.1. We're going to go through problems 9, 11, 13, and 15 from your workbook so that you can see some more examples, principles of how to apply this. And through repeated reasoning, you should be able to absorb some of these concepts and then try it out with more practice. On homework 22, I have some problems posted, and that'll be due Monday. So repeated reasoning is a good way to integrate mathematical thinking. You just do things again and again with slight variations till you see some of the patterns. And then this allows you to handle new stuff using the same tools. So the tool is related rates. Using processes, set up an equation based off some situation, partial differentiation, and then use the relationship between the rates that are shown in that resulting expression to solve some kind of problem. So the ladder, here's the ladder problem, but instead of looking at just X and Y, sorry, I'll flip those, X and Y, here's my H, I'm gonna look at some angle theta, which is the angle between the wall and the ladder. So I could put an angle down here, but that would be the wall and the floor. So this is my angle theta that I want. And so that's my situation. H is 10 foot. The bottom of the ladder is 5 foot from the floor, from the wall. And it looks like the bottom is sliding out at 1 foot per second. So that would be dx dt. That's the change of the x position. And we want to know how fast is this angle changing. So we want to find d theta over dt. So I got to somehow find a way to relate these quantities. And if I notice that x and h are specified, I can use the relationship. I'll use a different color now. For my equation, I'm going to set up cosine theta, not cosine theta. I have opposite, oops. I have opposite over hypotenuse. So that would be, I can erase with my pen if I'm fancy. Okay, sine of theta equals x over h. And because h doesn't change, I'm just going to leave it as 10. H is constant, so it's not going to be affected when I do any kind of partial differentiation. So then I can differentiate this using, not partial differentiation, implicit differentiation. So the derivative of this is negative cosine theta, d theta dt equals 1 over 10 dx dt. So I know, this is what I know here now. Given is, I know dx dt is 1. d theta dt, that's what I want to find. And what's my angle here, theta? Well, at this point where x is 5 and h is 10, I can say sine of theta is 5 over 10. When is sine of theta equal to 1/2? If you know your trig angles, that'll be pi over 6. So now I have an equation that I can solve for d theta over dt. And what I got when I solve that is 0.1155 radians per second. And that's in radians because I'm using this as radians. Make sure you have your calculator set for that. So that's an example that will be useful later on for some other problems. We can use trig situations to set up our problem. That's question 9. Question 10 is kind of fun. Maybe I'll do that one in class on Friday. It's a little more complicated. But 11, this is the first one from your homework. So this is to check your work. So if you got that, you can skip to the next one to check. But that's the simple x squared plus y squared equals h squared, where I got y is this distance, 0.3 from the problem. X is 0.4 because the Camry is headed west and its rate of change is 50 miles an hour. Yep. And then the focus is going north, so that's dy dt is 65 miles per hour. So we're looking at what rate are they approaching each other? What's the change of this distance here? This is h. We want to find dh dt. How is this distance changing? So here we can use this equation with partial differentiation, plugging in the values. We got, again, 98.75, which that's a reasonable number. Since they're going towards each other, it's not quite the sum of those. 50 plus 65 would be 110, 115 miles per hour. If they're going straight toward each other, that's the rate of change of the velocities. So it's something less than that. So just to put that in context, I think that's correct. Okay, let's look at 13. Slightly different situation. Again, if you'd like to and move on. Excuse me. I got 1.00 meters per second, which surprised me how small that number was, but here's the picture I drew. We got a guy in a boat. It's being pulled by this pulley. And there's another guy here pulling on the rope at a rate of 1 meter per second. So that 1 meter per second is also the change of this distance. It's our conserved. So h1 is square root of 65. Oh, wait, first I got that from 1 meter here. That's y. 8 meters here, that's x. And so I took 1 squared plus 8 squared, square root equals square root of 65. That's what my h is. I don't need h1. So since h is this distance, this is dh dt. That's how fast the rope is getting. It's actually decreasing. It's negative. Okay, so I want to know what I want to find. I want to find dx dt. So if you set up the equation x squared plus y squared equals h squared, your your implicit differentiation, and solve for dx to t. This is what I got. Check me on that. And then on problem 15, this is a different situation, so I do want to present this one for you guys. I got 3.81 minute. This is what I did. Here's my picture. It's a cone with radius r. Here's the height. The height is actually 2r, because we say the pile, the diameter is always equal to the height. Oh yeah, so the diameter is also 2r. But I like to use r because the volume equation is 1/3 pi r squared h. And so the question that's being asked, this dv dt, that's the change in volume. Oh, feet per minute. That's the amount being added each minute. So that's what's going on to my pile. And it's going to maintain this proportion of equal base and diameter. Some kind of physical property. So this question wants to know, how fast is the pile increasing? How fast is the height? So I want to know dH over dt. So I want to find. So this is trickier since there's two variables, r and h, and we saw that was more complicated at the beginning of class. But I'm going to make it simpler because since I want to find h, and I know r and h are always proportional, it's always the case that h equals 2r, no matter what's going on. If one of those is changing, the other is changing at a proportional rate, I can replace r in my equation as h over 2. So I could look at my equation, v equals 1/3 pi h over 2 squared times h. And that has the relationship that I want. I could also leave it like this. I could plug in h in. I get v equals 1/3 pi r squared times 2r. But then when I solve, I get dv over dt in relation to dr over dt. And this is actually what I did first. I found this, and I actually found dr over the dt, but I actually want to find dh over dt. So, and then I have to do, yeah, anyhow, this wasn't as simple to me. So I use this equation here. Kind of some trial and error is what I found. And so with this equation, once I do implicit differentiation, I get dv over dt. Oh, and I'm going to simplify it first as 1/3 pi h squared over 4 times h. So that's 1/3 1 over 12 pi h cubed. So if that's my volume formula, I'll say dv over dt is 1 over 12 pi 3h squared dh dt. And now I got some numbers to put in. Okay, it says the height of the pile is 10. So I'm going to say 10 for h. And the dv dt is 30 feet cubed per minute. This will be in feet squared because it's squared. And so then I'm just solving for dh dt. And so just because I want to make sure I'm right, I'm going to work through this again. This is times 12 divided by pi. Well, let's cancel that first. So this is times 4 times pi divided by 100 feet squared. That'll be what dh over dt is. So those will cancel. And I get 12 over 10 pi foot per minute because 2 of the feet's is canceled. So let's check what that is. I think I did something wrong here. 12 over 10 pi. 3.769. That's slightly different than what I just told you. Ah, it's because I forgot to square my 10. 3.769. That is more pi's work. So let's double check against what I did before. Multiply by 4 divided by pi. Oh, but I do have to divide by pi. Okay, again. Like I have to check my work again. It's 10 over 12 divided by pi. Since this and this go on the bottom. Zero point 0.38197. Okay. Foot per minute. That's my final answer. Double check my work. That looks good. Yep. This answer was a factor of 10 off. I forgot to square my 10 here in my original problem. Yep. So good to check it. I am now confident this is my answer. And so hope that helps give you some examples to check and see. Your homework, your first problems will be 16 and 17, along with some odd ones from the textbook. For 16, your hint is use law of cosines. Law of cosines is something that applies for any triangle. It doesn't have to be a right triangle. You just need to know theta, and the opposite side to it is C, and then A and B. So this is a relationship that holds for any triangle. And so you can use that. Answer 16. And 17 is pretty involved. I actually had to do 2 equations in it. Try it yourself first, but I actually had to set up 2 triangles, x1, x2, h1, h2. And then this was just 12, so I left it like that. So I had 2 equations, x1 squared plus 12 squared equals h1 squared, and x2 squared plus h plus 12 squared plus h2 squared. And the cool thing is that h1 plus h2 is always equal to 39. So I had to do the whole process twice. And if you want to check your answer, I'm going to check it in class. These are homework. Very good. Okay. I hope you guys find these problems fun. I enjoy doing these. They're really cool to work through. So we will see you in class on Monday. You have a good weekend.